Our next segment is called Eye on Science, where we take a look at some hard science and maybe try to learn a thing or two. Here's a story from Wired. Researchers levitated a small tray using nothing but light. That is cool. A magic carpet based on this light-induced technology could carry climate sensors high in the atmosphere. That is a little confusing, but we might see why that is actually possible. This picture in Wired has nothing to do with the story. It's just a floating orb for some reason. And the story doesn't have any floating orbs in it. It has floating a sort of I mean, I hate to tell you, but little flying saucers are what it looks like they're making here. These are, let's see, we're talking about Mohsen Azadi, a researcher at the University of Pennsylvania, and his lab mates huddled around a set of vacuum changer. They stared at the lights. They made something levitate. They made these 2 centimeter. They're sort of like little, like half-inch long, little flying saucers, and here's a picture. There's a little GIF of it on this Wired story. You can find all these stories on our website, scienceafpod.com. And did you see that little flying saucer? Here it comes again. It's levitating by light. Ooh, and it flies right past. Very cool. So what's happening here? Well, a lot of the stories are likening this to a solar sail. It's not exactly a solar sail. That's not quite what's happening. Let's go to the drawing board for a second, and I'm going to try to draw a little bit of what's going on here. A solar sail is a big, shiny mirror or white sheet in space. It's kind of a 3D thing, and when you either, if there's a sun nearby, there's a star, or you could have a little spacecraft with a laser, shooting a laser at it. Pew! And what happens is the light beams, the photons, the light itself, bing, bing, bounces off of the solar sail. Actually, light doesn't quite bounce. It sort of is absorbed and re-emitted, but there's a net momentum change. The momentum of these little photons changes from this way to this way, and the conservation of momentum says that extra momentum goes right into the sail and shoots it along. And excitingly, we've heard that we might be able to reach another star, not us personally, but we might send a probe that goes to another star, and this is a probe. There's a probe being shot by lasers in the sun towards another star, and we could reach it within 20 years, within a lifetime. I might not be around in 20 years, but you might. It's possible that we could see another solar system in our lifetimes with a solar sail. That's really cool. Love it. Great technology. But that's not what this story is about. This story is about a little tiny 2 centimeter hovering flying saucer powered by light. And the way this one works, it's got a couple layers. The top layer is a thin mylar, and that's sort of light neutral, reflects light. Like the bottom reflects light, the top reflects light. You get no lift. It's a draw. But what they've done is they've sprayed a bunch of carbon nanotubes, like little furry beard of carbon on the bottom of these little flying saucers, okay? And this is the genius part. Carbon nanotubes are heated. They get hot. They heat up when light hits them. That's cool. The mylar on top doesn't heat up, so it stays neutral. Bing, bing, bing. Things are bouncing off. The nanotubes, however, when light hits it, the temperature goes up. Temperature. Here's a thermometer. Boop. The temperature is going up because light is hitting the nanotubes on the bottom. And it's not the light reflecting off it that's creating the lift. It's little molecules of air. Here's little molecules of air. They bounce off of it. Now, air bounces off of, the top, and air bounces off of the bottom. That's also a net zero lift effect, unless the bottom is slightly warmer than the top. Then when these little molecules, here's a little H2O, pew, flying through the air, pew, and it hits the carbon nanotubes and it gets stuck for a second. And it heats up because the carbon nanotube is a little bit hotter than the air. And then, pew, it gets shot out a second later with more momentum than it started. The carbon nanotubes actually heat up the molecules that hit the bottom, and it shoots them off like a little gun, like a little air popcorn machine. So at the top there's air particles hitting and bouncing off. On the bottom there's air particles hitting, getting stuck, and shooting off. And what does that do? That's extra momentum again, and boop, we have lift. This is really cool. This is different than a solar sail. It's more like, where are we back? Let's go back to this thing. It's more like a little a jet shooting off the bottom of a saucer. It's a flying saucer. I'm just gonna say it. Maybe the aliens that the Navy has recorded are using this technology, or maybe that's just humans who are not telling us that they have this technology. So here's where it talks about, this story talks about the mylar on the top, and then each nanotube a few atoms across, about as long as a strand of hair wide. So it's a little, like almost microscopic little hairs of carbon on the bottom. And an ambient gas, after an ambient gas molecule from the air collides with a warm object, it picks up a small amount of energy and bounces off faster than it arrived. So this is a little solar-powered jet that shoots down. Thermodynamics indicates that a hotter particle is a faster particle. It sure does. So, here's a cool GIF of a little thing flying around on these lights. So the light is not lifting this. The light is heating it, like a little solar heater, and the air molecules are shooting off like a little jet on the bottom. And this is a side view of something flying around. Very cool. So what are the uses for this? Well, one idea is that they're thinking of putting these in the ionosphere, the mesosphere. Let the mesosphere-like pressure. So yeah, they're testing it in mesosphere-like pressure. Mesosphere is one of the upper parts of our atmosphere, where it's hard to fly things because airplane wings don't have enough purchase up there. The air's really thin, but it's too low have like orbiters, satellites, because they'll burn up. So it's in between the airplanes and jets can fly, and where outer space orbiters and satellites fly. It's the in-between zone. It's hard to fly stuff in that area. We don't have a lot of science research in that area. So they're talking about little flying carpets that are solar powered that could just circle around, flying around, and who knows what they could do. They could be spies, or they could be solar collectors and send power back towards Earth. They could be used for good or for evil, like all science. Let's see, this is just another story. Same. This is eurekalert.org, levitating objects with light. Basically, same story. This is researchers at Caltech have designed a way to levitate and propel objects using only light, using nanoscale patterning on the object surfaces. Basically the same thing. This is at Caltech. The last one was in Pennsylvania. And here's just a Wikipedia article on radiation pressure. This is what I was talking about with the solar sail. The incident momentum, the reflected momentum. This is a photon of light bouncing off of a flat reflector, and the force momentum change, the force is equal to the momentum change. That's how a solar reflector works. There's a bunch of equations here if you want to do the math yourself. Look at all these cool pictures of, there's a Hale-Bopp comet, the Pillars of Creation Nebula. Okay, I don't know what all that has to do with what we're talking about, but that's it. Levitating, tiny, small, flying saucers. First step to large flying saucers.